Alright, so far you already know that compression is reducing a file size by impacting one of its attributes. And the two types of compression are lossy and lossless compression. You may already be familiar with one lossless compression technique, run length encoding. To understand this video, you would also need to have some knowledge on the ASCII character set. In this video tutorial, I am going to show you another, slightly more complex lossless compression technique. It's called Huffman coding. As you know, RLE is not always reliable, but the technique I'm about to show you will guarantee a large reduction of file size every time. Okay, let's start by looking at the following. Silicon OASIS. Using 7-bit ASCII, how many bits does Silicon OASIS use up? Remember that spaces count as characters. Pause the video here and work out your answer in your book. Okay, the answer is 91 bits. We know this because there are 13 characters in Silicon OASIS. Multiply 13 by the 7 bits you get per character, and you'll have 91 bits. Alright, let's use the Huffman coding technique and see how many bits we can reduce this by. As you watch this video, follow along by copying down everything I do in this video into your book as I am doing it. First, we start off by noting down every character that appears at least once in Silicon OASIS. Do not repeat any characters. So that gives us SILCON space A, and that's it. Next, state how many times each character appears. S appears 3 times, I appears 3 times, L appears once, C appears once, O appears 2 times, N appears 1 time, space appears 1 time, and A appears 1 time. Now, with this information, we're going to create a Huffman tree. Give yourself plenty of room, maybe 10 lines should be enough. And we will note down the characters from right to left in order of their frequency. Least frequent on the right, most frequent on the left. That gives us this. You can see I put S and I on the left because they both appear 3 times. It doesn't matter which one I put on the far left, as they both occur the same amount of times. Feel free to pause the video here to note down this order. Now we are going to branch these values together by adding the smallest frequencies. It does not matter which ones you branch together, as long as they are the smallest values at the time of branching them. As A and space appear once, I'm going to branch them together. You'll notice I put a 2 here, because 1 plus 1 equals 2. This is important for error checking later. Now I'm going to add N and L together, also giving me 2. Next, C with O, this time I get 3. Now I'm going to branch the two values together, giving me 4. Now I will branch S and I together so that I get 6. Next I will branch the 4 with the 3, giving me 7. Finally I join 7 and 6, giving me 13. It's important we got 13 at the top of the tree because there are 13 characters in Silicon OASIS. This is a check to ensure we got it right. Pause the video or go back to make sure you copy down everything I just did and understood it. At this stage, Huffman coding can feel complicated to some, so feel free to look back at this process before we carry on. Alright, now we are going to number every branch using the binary digits 0 and 1. Each pair of branches needs a 0 and a 1. It doesn't matter which branch gets 0 or 1. We can now use the branches to encode each character with a binary code. The process here is really simple. We start from the top and navigate our way down the tree to the letter or character we are looking for. For example, to get to the letter S, we pass two branches, 0 and 0. This means S is 0, 0. To get to N, we pass through 4 branches, 1, 1, 0, and 1, meaning N is 1, 1, 0, 1. Use this process to encode all of the other characters in Silicon Oasis. Pause the video here to give yourself time to do it. And here are the answers. Pause the video here to check you were correct. Now we move to our final step, encoding Silicon Oasis. Using our newly formed Huffman Code key, we can spell out Silicon Oasis using binary. It gives us the following code. Now, remember back to the beginning of this tutorial where we found out the ASCII encoded version of Silicon Oasis used 91 bits. Well, this only uses 37 bits. That's a 60% reduction in bits. And that is Huffman encoding.